Well, hello everyone. Welcome to Unit 4 of the Precision Farming Systems course. This is your instructor Kevin Butt again. This unit here, we're going to jump into Unit 4, Yield Monitors. And Yield Monitors is kind of where Precision Ag got its start. If you remember back to the first unit when we looked at what is Precision Ag and how it came to be, the whole goal of precision ag was, looking for that variability, looking for, the differences in that in a field, and being able to, start figuring that out and trying to produce more. And yield monitors is kind of where that started. We figured out how to record the yields coming into a combine. We combine that with a GPS, and lo and behold, we have a yield monitoring system. So that's kind of why yield monitoring is and why it came to be, and there is still a huge emphasis on it in these days. More and more combines have it. It's a fairly common thing to see. So there's a lot of importance goes to this. So let's go ahead and begin. So to look at yield monitoring, basically there's three main methods or three main ways that we can utilize to measure yields. The first one is kind of what we call the collect and weigh method. And what that is that we would combine, harvest the crop, and, we'd weigh out a load, or we'd measure how many bushels we had. A lot of time this was based on a whole farm or whole field. Prime example, my dad would combine a field before we had yield monitors. Would combine a field, and once we got done with that field, we looked at how much crop was in the bin, a rough estimation, and then we could say, well, that field was 60 acres, and we had X amount of bushels, and we could calculate out, what the yield was. The problem with this method is, as you can kind of see there in red, is that we can't see those field variations. We don't know where the good parts are or where the bad parts in that field are. So that's kind of one that has been around for a long time. Another method, the second method, is what we call the batch method. Kind of along a similar method as the first one, but here's where maybe we're going to break it down into smaller areas. So we could say, hey, a combine out a field, imagine taking out a test plot. So we combine out a strip of the test plot. We dump the crop into in a weigh wagon. We weigh it. We measured out, here's the area, here was the width, and calculated the area. So yeah, a little bit smaller, a little bit better estimation of yields, kind of got it down into smaller areas, but it was still, these are still not site specific. We don't know what parts of that strip or what parts of that area were good, which ones were worse. So that is, once again, kind of where we don't see a lot of that anymore. You still see it, but we really need the technology to see those differences in the field. The third one is the instantaneous. And this is kind of what this whole unit is based on. And this is where we're going to be measuring yield, or measuring how much crop is coming through the combine or the harvester at any given time. And then we tie that in with the GPS. So the GPS that's on the combine, and it says, yep, here's what my location. The combine says, okay, at this location, here's what I had for yield. Records into the system, and so that is what we're looking at. So, and as we can see here, this is site specific, and this is what we're really looking for. So that's the three main ways that we can obtain yield data. So first two, it's not really good data. It's a good estimation or a good average. The third one is where we really see, the differences in the field. So basic components of a yield monitoring system, and we'll kind of begin with this. Yield is a calculation of what? You talk to a farmer, you say, okay, what were your yields this year? They're going to tell you, my corn yield was 180 bushel per acre or 220 bushel per acre. So it's always a calculation of how many bushels do we have for a given area. So for instant yield data, we have to measure three things to get that calculation of bushels per acre. So the first thing is we look at the bushels. So what we need to do is we have to record or monitor how much grain is coming through the combine at a given time. So this would be our rate of grain flow, and that's going to come back, and we're going to take a measurement, and we're going to equate that into bushels. So that's the first measurement. The other two measurements are a combination that give us our acres. And the first thing we need to know is how fast is the combine going? So the speed of the harvester. We have to combine that. That's going to give us our distance, but then we have to combine that with how wide of a swath are we taking out. So we take the speed, combine that with the width of the head or the width that we're harvesting, and that's going to give us our area. And we put that into acres for us. You go across seas, it's not acres for us. It would be more of hectares over there. So those are the three things that we have to measure. So how do we accomplish that? Well, the basic components, we could see there's 5 basic components that we have to have on that combine to obtain those 3 measurements. So a grain flow sensor, grain moisture sensor, a ground speed sensor, header position switch, and a display system. So we'll kind of break down each one of these a little bit more specifically. So the first one is a grain flow sensor. So it's a sensor that basically is going to record how much grain is coming into that combine at that given time. So there's a couple different methods of how that takes place. Typically, depends on the method, but most of the systems are still mounted in the path of clean grain, which for us in a typical John Deere or a Case or a Lexion combine harvester, typically that's going to be in the clean grain elevator system. Somewhere along where the grain is coming through, is getting thrashed, drops to the bottom of the combine, moves its way up towards the top through that clean grain elevator. Somewhere along that clean grain elevator is where we're going to see that grain flow sensor. Typically, they're mostly at the top of the clean grain elevator system. The most common system we see out there is what's called the plate displacement system. And there's a couple images there to kind of show that to you. So basically what it is, you can kind of see the image here on the left. This is kind of, I commonly refer to it as the catcher's mitt. But basically as the grain comes off the combine, if you look at the image here on the right, as the grain is coming off up the top of the clean grain elevator, as it's getting thrown forward into the auger that's going to take it into the clean grain tank, that sensor, that plate sensor is going to sit up there, and basically what it does, it records how much force is hitting that plate. So it's a force sense system. It's going to dictate how much force it's going to take, how much force is going to hit it. Basically, it's electronic signal it's picking up. If you look over here at the right, on this image, there's the plate kind of sitting there right behind it, that black colored object. Basically, it's a mass of wires, and it's just recording how much force is hitting it. So the more force that's hitting it, well, there's a lot more grain hitting the system, which means that we're having a higher yield system in there. So fairly common system. Just kind of give you a reference, the clean grain elevator that I was referring to, you can kind of see what's highlighted here, yellow in this combine. So as the grain's coming into the front of the combine, kind of goes up into the rotor system where it's thrashed, that grain falls to the bottom, and then it gets augered up around, typically on the passenger side, as we would call it, up the passenger side, up to the top of the combine where it goes into the tank. So that's what we're typically referring to with the clean grain sensor. Now, we've seen a few changes recently in that grain flow sensor. One of the most ones that we've seen recently is the yield sense system. This was put out by Precision Planting a few years ago. They were kind of looking for more efficient ways, better ways that we can do the yield monitoring in a combine. So some of the key things that came out with this system is they originally wanted to put a scale on the combine. They just wanted to scale it. And their whole goal was that it would be a one-time calibration. You'll see where that calibration comes in later. They gave up on the scaling system and came up with some innovative ways of doing it. One of the things that they did is on that clean grain elevator, the chain and paddles. The paddles that are typically used in that in a typical combine. Typically, it's a really thick rubber paddle, takes the grain up to the top. What they did here is they came out with a hardened plastic one, and it's somewhat concaved. And that concave shape kind of does something that has a unique properties once that grain gets towards the top of the clean grain elevator. So So they had a unique paddle system that they have put into the combines. The other part is where they mounted the clean grain or the grain flow sensor. So you can see kind of here there was some of the imagery they got received this from them. And so their sensor sits right at the top of the clean grain elevator, what's there in blue. So that grain comes up, and that concave shape of that paddle is going to force that grain into a very precise area on that grain flow sensor. So it's going to give us a better indication of yield, better indication of the crop that's coming through. So, and as you can see in the white part over at the right hand side, that's where the existing flow sensor is. So in this example here, we could see we have corn that's averaging 70 bushel per acre. So there's not enough corn coming up through the system that very little of it's going to get over there to the right-hand side and hit that existing flow sensor, the ones that we would see coming from other manufacturers or coming directly from the factory when the combine was built. And then we can say, okay, what if we get into 180 bushel acre corn? And once again, where their sensor sits at the top, it's going to be a better indication of yield because that crop is forced into a certain area. Versus as it goes over there, you can see we have a lot of grain coming into the combine up top. So now we have the chance for some corn to get deflected. So we have some additional ones that are going to hit that paddle and maybe start giving us erroneous or more readings than what's actually there. And then if we get up into some higher yields, like we're starting to see now, 250 bushel acre corn, a lot of that is hitting that flow sensor, and there's even some backing up into it, so in that existing flow sensor. So once again, it's going to give us inaccurate readings, whereas the precision planting system is going to give us a better indication. They've done some trials with this, and the accuracy, the percentage of accuracy, what percent of error that they have, is a lot less than what we see with the traditional systems. So that has kind of been their key claim to fame. When it originally came out, it was very limited models of combine that it was adapted to. Since then, they've expanded it out, and there's a lot more models of combine that can utilize this system. So, but force plate system, that is the most common ones that we're going to see out there in this day and age. Another type of a system for grain flow sensors we see out there is what's called the radiometric system. And basically what this is it's a pair of sensors. One is a detector, one is a sensor, and basically it's measuring, how much radiant energy. So you can kind of see by the image down there is that on one side we have a source, and it's basically beaming an isotopic source. Typically it's americunium-241 they call it. So somewhat a little bit radioactive if I remember my high school chemistry class or my college chemistry classes from way back when. But basically that source will emit that, and then there's a detector on the other side that is looking for that. Well, as grain is coming up through that grain is going to obstruct its path. So the more the grain that goes through, well, the less of that isotopic source is going to get picked up by the detector. So once again, you kind of have to calibrate, how much grain coming through equates to how many bushels. So don't see a lot of these. These are kind of fairly rare. You may see them in a few other cases with a few other crops, but typically what we see in a typical modern combine, you're not going to see this. As well as you're not going to see much of this. I have hard-pressed to see this being used anymore. So this is what's called a load cell system. And basically this is where we're going to actually weigh the grain. And you can kind of see, it actually did find an image somewhere out on the internet where someone had this idea how they were going to do this. So you can kind of see basically the auger kind of rests on a pivoted arm, and on the other end is a load cell. And that load cell is going to convert how much pressure, or the weight that's being applied into electronic signal, which then we can calculate and turn into bushels. So this is what precision planting, kind of something similar. They were looking at just measuring the amount of grain in the combine and just weighing it out. They just found out it was too hard. So this is an idea that was out there, but I have yet to see one actually in place. So, but it's something still worth noting. So that's a grain flow sensor. So that's kind of a key part to this whole yield monitoring system, and that we have to have that. So the next key piece that we have to have is a grain moisture sensor. And so the question is, why do we need to measure moisture? Well, grain at different levels of moisture is going to come up with a different amount of weight and also a different amount of volume, which is our bushels. So if we know the moisture and we have the weight that we're getting from the force feedback system, we can turn that into bushels. So once again, a moisture sensor is going to be located in that clean grain auger, because that is the best place to get to mount it and have access to it and access to the grain that we need to measure. So once again, we see some variations in how they're built, but they all use the same basic principle. They use a capacitor. And as grain passes between two metal plates or a metal plate that has electrodes on it, basically that capacitor is measuring how much resistance is it taking, or what is it taking for resistance. And so the thing is, the less resistance we have, the more moisture, because water is an excellent conductor of electricity. So the more moisture that we have in that grain, well, the less amount of resistance it's going to have. So once again, we measure the amount of resistance, electrical resistance we're seeing as that grain is passing past the metal plates, converting that electric signal, which then converts it into moisture percentage. So here's a typical example of a grain moisture sensor, what it looks like, mounted there on the clean grain elevator. I'll show you a quick little video here that kind of puts it in, it's a nice little animation video that kind of shows you how that system works. And this is a fairly common type of a moisture sensor we're going to see. So here's the video. So, if you went back in that video, basically, I'll kind of jump back into here. Upper right-hand corner, that's an electronic eye. So as the grain is falling down past that sensor, once it hits that electronic eye basically signals that augering system to start augering out the bottom end. So that is a typical moisture sensor, what we see. There's another one that's out there in the market that you see, what you see here. This is mounted at the bottom of the clean grain elevator. And as the grain's coming over there from the left-hand side, basically it's just a metal plate that kind of sticks up in there, and it's just measuring the moisture there. So sits in the bottom, does the same functions. So anyway, those are the two main components that we see in a yield monitoring system. So we're going to go ahead and stop this video series right here, and we'll proceed with the next video here shortly. Thanks.